Well, it's the next day. I want to do one quick correction on something that I did yesterday that I was wrong about and miswired. My schematic was wrong. So I will go back through and try to double check things at night and whatnot after I'm done, just to make sure everything is as sound as possible. And I made one mistake, so I want to go through it here. So the way the vintage air system works, it's pretty simple. You get an active low signal from the vintage air ECU, okay? That turns on the compressor relay. Boom. That fires, which effectively puts 12 volts down on the compressor wire. Now the compressor wire then goes down through the trinary switch, and if the trinary switch has a pressure, sees a pressure between 30 psi and 460 psi, it turns on the compressor. It allows current to flow through. Great. The fan, on the other hand, when it is basically the active low goes back to the fan. So here we go, fan on, active low. So what it does is it sits here and waits for the pressure to get above 254 psi. So as soon as this goes up from the minimum, when the pump isn't engaged, the pump will engage, it'll go up, and as soon as it hits 254 psi, it turns on the fan. And it provides a connection between ground and the fan on active low signal, which fan on active low then goes up and turns on our two fans through the control lead. Because they're all active low, it's almost like an open collector, but it's active low. Basically, any one of these points provides a ground. Those fans are coming on because the relays will fire. But what I did notice that I did wrong in looking at the vintage air schematic last night, I swapped the leads. So the compressor should be on the black and green leads, and the fan should be on the blue leads. I did it backwards. So I just got to swap the pins on that connector, swap the blues with the greens, blues with the black and greens, and I should be good to go. So I just wanted to correct that real quick, in case anybody picked up on that. That was a problem. I will update this schematic, get that reposted. But yeah, I just wanted to cover that before I get into today's video. Okay, so now I'm going to start working on the power distribution. I like to use a disconnect switch. I know some people use them on a terminal, some people use them whatever. I like to mount one right here. I'm going to mount it to the core support. Should be pretty good to go. So first thing I do is I also like to ground the core support. So I've made a little ground stub that comes off the disconnected portion of the battery ground. So the battery terminal will go to this lead, nothing else will go to that. So when I switch this, the battery will be completely isolated. Anyway, so I like to do a quick stub ground off the terminal to the core support itself. That gets me a good solid ground to the core support. I'm right here, you might as well do it now. Then I'm going to run this and run a stub from here, this terminal, over to the battery post, and I'll show you how I do that. The section I'm working on is right here. So this is the battery post terminal. That's the switch we were just looking at, grounded to the core support, and then I'm going to run a 1/0 wire over to the ground block that I put on the brace over there. Okay, let's talk about electrical connections in general. Now, a lot of times you'll run into terminals like this that have a compression type termination, where you put the wire in and you compress it down with a screw terminal. The problem with that is, if you put a wire like this in there, yeah, you can get it nice and tight, but over time, that's going to move, it's going to rock, it's going to vibrate, and it'll ultimately loosen up because you don't have a good positive compression surface. So one way to deal with that is to tin the leads with solder. I'm not a big proponent of that because as soon as you do that, the solder wicks up into the cable, everything gets hard and really difficult to manipulate. A good crimp is usually all you need. You shouldn't even need to solder these ends if you have the right crimping tool. Like in this case, it's a hex tool for the 1/0. And that works fine. That works good. But on this end, or any place where you have a compression terminal, I don't care how big or small, you should always use a ferrule on it. And that way, the wire is compressed as much as you're going to get it. The ferrule will then go in here and be pushed down by the screw, and it won't tend to back out at that point. So let me show you what I mean here. So in this case, I've got some 1/0 ferrules that I want to use. Let's see if I can find a place to set this. My bench is out of control. Okay, so I have some 1/0 ferrules that look like this. And what I got to do is just slowly work that on there. And with this multi-strand stuff, you got to be careful not to get too much outside. Now, I got a ferrule on there. I crimp that. That gives me maximum density in here, but it also gives me a good surface to screw it against. So let me grab the crimp tool. And for large stuff like this, you want a fairly, the big boy. And this one's adjustable. It's set to 1/0. You just get that up in there as tight as you can get it. I like to square up the other end just because I'm anal about it. And then you just press. And it will not go anywhere, except for it's still slipping. All right, I got to get that a little more compressed, but that's the idea. I guess I got to go down to a 2-terminal, which is a little crazy. I haven't tried these ferrules yet, as you're probably catching on. There. Now we got it. Yeah, it's not the prettiest ferrule, but it is compressed. So that's the idea. Now you've got a solid surface. When you stick that into your terminal, it will comply. There, I just gave that a few more crimps. That works a lot better that way. But again, you're just trying to compress that cable down as much as possible. It can't come off, and when you now screw down on it, you're screwing down onto a solid surface that won't back out on you. Anyway, okay, we'll give that a go. Okay, switch is installed, ground cables, so I got a ground from my post to the switch, from the other side of the switch to the core support, just so that everything that's grounded off from that has a good solid place. And then from that post, I'm going to run it back to my ground block with this. So that's next, and hang on. Okay, so now I have run my battery cable positive from the terminal over to the block on the firewall next to the tank. I have run my ground also over to the block here, and then I've run a ground cable down to here where it will be bolted to the frame. But I've got to run a ground from that point over to the motor too. So I haven't bolted it in yet, and I still have to run this cable from the positive block down to my starter. So that's what I'm going to do next. I'm going to put the car up in the air, but this is the way I'm doing it. Now I use these little rare earth magnet clips. They actually hold really well to loom stuff. They're nice because you can move them around a little bit if you need to, and they tend to hold on well. In the end, you don't care if it slips or moves a little bit as long as it, you know, kind of holds it to where it's supposed to be. So that's looking good. I'm going to lift the car up, run the cable to the starter. Probably going to heat shield that a little bit depending on where I have to pass under the headers, and then do a similar thing for the battery ground. Okay, so I have taken the starter cable down. I put some heat wrap on it. Put that on the starter, and then the ground cable I've run down and applied it here. Still got to tighten that up. So I've got to ground the block to the frame, to the battery and the body, and the power goes to the master block and down to the starter. So I'm good under here. All right, here's where we're at. Get the power and the ground back to their respective blocks. Got the battery block here, comes in, feeds the starter. Alternator feeds in through this 150 amp fuse, and then there's a 60 amp fuse, I think, that feeds the continuous 12 volt bus in the under the dash. Then I have a relay fed 12 volt switched, so when the ignition switch is on, this 12 volt is live through the relay. That is also on a different bus bar under the dash. So that is kind of how that plays out. I've still yet to run my ground that I got to run from that block back up to the ground block under the dash, but that'll be next. And I'll show you, hang on a second, let me show you what I'm talking about when I'm talking about blocks. So here you go. I keep talking about these 3 terminal blocks under the dash, and this is the plate. This mounts up under the dash, like so, and I got 3 terminal blocks set up. I've got some slots for cable ties so I can organize my wiring once it's in there. But the idea is then everything under the dash, I have very easy, clean home runs. 12 volt switch, ground, and 12 volt constant. That's the idea. And the back half is held up with some rare earth magnets, and then there's a screw that holds it all tight in the front. And I'll show you that when I get it in there. But that's what I'm running the cables to inside the under the dash. So yeah, just wanted to give you a look at that. So it looks like the last thing I have to do on this schematic for power distribution is now get power to the fuse block. And I'm going to use this 6 gauge. It's plenty big for this. Again, anywhere where I'm putting it into a compression or clamp type fitting, always use a ferrule. That won't come loose, or if it does come loose, it'll be a lot less likely that it'll ever slip. It'll actually grab it better as you clamp it. So I pressed in a ferrule on this end already. I'll put that in my my battery block right here. Then I have to route that back down and around and over to this. Okay, that's it. Power distribution done. Ground through a switch. The core support. Back around to a terminal block. Then my secondary block on the firewall for the power distribution. That's live battery right there. Then I run from the alternator back. I've got a relay, switch on relay for switch 12 volts. I'm also got 3 extra spots in this for other things that I might need. But it's nice to have a relay block, and I kind of like the form factor. I've heard not so good things about this, but we'll see. Anyway, everything is kind of loomed up like I want it. I've got to go through and do all that at some point, but I want to put the chassis harness in next just to make sure that, you know, like I know I have a starter wire that has to come over here. That's about it for the engine harness, though. So I'm not sure exactly the order I'm going to go next. I might go under the dash, start putting in the terminal blocks, and then get all the AC wiring done to the terminal blocks and everything else. Then get my start with the Dakota Digital stuff for the dash. So that's the plan.